So there's how we do tangent of 405. So they give me 405. It's more than 360. I subtract 360. Take away a full circle, you get 45. So again, 405 means all the way around 360 and 45 more. It's 360 and 45 more. So you really just end up at 45 degrees, because all that matters is where you end up. 45 degrees. Go to the unit circle, 45 degrees, cosine's root 2 over 2, sine's root 2 over 2. Tangent is sine over cosine, root 2 over 2 over root 2 over 2, 1 is our answer. All right. To give you these kind of questions, 24 pi, just laugh at them. That's 12 2 pi's, isn't it? That means they just went around the circle 12 times. But who cares? It's all about where you end up. They ended up right there. That's 24 pi. It's right where 0 is. 24 pi. And so what? What's the coordinates there? That's over 0 up 1. Cosine sine. What's the sine? Oh, it's not over 0 up 1. That's over 1 up 0. Over 1 up 0, huh? What's the sine? 0. Next question. Good? Since I do like this, jump ahead. Okay, cotan is 7 pi over 3. How do we do that? I would stick in the 180 right away. I just don't like pi stuff. So you don't have to. If you're good with 7 pi over 3, if you happen to know that's a full circle and pi over 3 more, great. Just do that. That's even quicker. But I've noticed over the years a lot of students get confused. So you can always just put in the place of pi 180. Pi is 180. You with me? So that's 420. If you work that out in your calculator. And then 420, that's more than 360. So you subtract 360 and you get, what's that, 60 degrees? So this is really cotan of 60 degrees. Remember, cotan is upside down of tangent. So it's cosine 60 over sine 60. Am I going too quick? You tracking with me? So I put in the place of pi 180 degrees because pi is 180. I popped in 180, worked things out, got 420, subtracted the full circle. It's 60. Cotan is cosine over sine. So now you go to the unit circle, find 60 degrees. 60 degrees is right here. And cosine sine, x is cosine, sine is y. So a half over root 3 over 2. So it's half over root 3 over 2. Grab the denominator, flip it up. It's a half times 2 over root 3. The 2's cancel. It's 1 over root 3. Or if they want you to get rid of the denominator, the root, then multiply top line by root 3. Good? We okay? See how you can do that without a calculator? Find those values using the unit circle? We good? All right. I'm going to keep... Yes, good job. Remember how the signs go? I'm sure your trig teacher told you all students take calculus. It's not a true statement, but it helps you memorize the thing. Maybe all students should. All... So what does it mean about the signs? All 6 trig functions. Sine, cosine, tangent, cotan, secant, cosecant. They're all 6 positive in the first quadrant. S, which means sine, only sine, and of course his upside down, cosecant. They always go together, right? You always do the same thing as your upside down reciprocal function. So sine and cosecant only are positive in the second quadrant, right? First quadrant, second quadrant, third quadrant, fourth quadrant. Only sine and his upside down, cosecant, are positive in the second. The other 4 are negative in the second. And then in the third, only tangent is positive and his upside down. Who's his upside down? Who's the upside down to tangent? Cotangent. Only those are positive. The other 4, sine, cosine, secant, cosecant, are negative in that quadrant. Fourth quadrant, who's positive in the fourth? Cosine and his upside down, which is secant. And the other 4 are negative. So that tells you where the trig functions are positive. All students take calculus. So that's where they're positive. So then when they say, okay, what quadrant, if sine is less than 0, that means negative, doesn't it? Cotan is also, so if sine is negative, what quadrant might we be in? If sine is negative, we can't be here, we can't be here. They're all positive here. Sine's positive there. So sine's negative, we're either in the third or the fourth, if sine is negative, right? And then which one of those has cotan negative? Well, tan's positive here, so we're not there. We're in the fourth quadrant. Everybody see how I found that? On we go. Okay. Cosine of theta is minus 24/25. That's all they're giving you. And theta is in quadrant 2. Find all the other trig functions. Just from that one? Can we do that? Can we find all the others just from that one? Yeah, I'm going to put it on the unit circle, do the Pythagorean Theorem. Now, if you click on the help button, they'll show a different way. They'll show the formula sine squared plus cosine squared is 1. That's a good way. That works good and everything. But in the next section is a 6-4. You'll have to do it this way anyway. So I figure, hey, I might as well not learn two different things. Let's just get going on what we're going to have to learn in the next section anyway. And it's super important for calculus. You do a lot of this, especially in calculus 2. It's one of the ways of doing integration. It's called a trig sub. It's a way of making an integral happen, which is the opposite of a derivative, which is area under a curve. And anyway, you do it using this, like a ton. So it's really, really useful. So let's find it. So I'm going to draw a unit circle, and I'm going to make it the case. I'm in quadrant 2, so let me draw a little circle here. I'm in quadrant 2, so I'm in this section. I'm just going to draw some angle. I don't know where I'm just going to put it kind of somewhere random in quadrant 2. I don't know exactly where it is. Just hit it in quadrant 2. There it is in quadrant 2. And now I'm going to make a triangle in that quadrant that fits the truth of the statement cosine theta is negative 24/25. Remember when you make these triangles, you remember this from your trig days? That we always make them to what axis? The x-axis or the y-axis? We want to make reference angles, is what we're going to do. We want to make our triangles always go to the x-axis or the y-axis. In particular, it's the x-axis. You want to go here. In other words, what you don't want to do, let me be clear with you. So you guys, how am I doing right now? I better not be doing the Charlie Brown teacher voice for you. If I am, tune in, change the radio station, tune in. Don't worry about what you're doing this weekend. Forget about all your other classes. Who cares about them anyway? It's all about math. Bio, Trevino is, I don't know, My daughter she's taking the same bio you are at Clovis. She says that class is terrible. Bio 11, that's it. It's the science bio. Yeah, it's ton. She says it's just a ton of information. Like half the class failed out. And yeah.
The second semester is like
Bio 11B?
Yeah, I took both. The second one's like way more.
Is it more? Because then it's other animals, or it's not humans. It's
animals and bodies.
Oh my goodness! I won't mention that to my daughter. She's not enjoying it. Anyway, forget about that stuff, Trevino. Forget about all that stuff. Dial in with me right here. It's really important that you see this. If you go to the y-axis, you're done. It's not going to work. Do not make the triangle go to the y-axis. It has to go to the x-axis. Why? Because the original 0 degrees started on the x-axis. If they made 0 on the y, then we would make everything go to the y. This is called a reference angle, meaning the trig functions will be the same. You put your theta right there, because it's at the origin, but to the x-axis like that, right? It's going to the x-axis. It'll be the same. So anyway, enough said. Let's move forward. Now, with that in mind and that in place, I'm going to make it the fact that the cosine is fitting that truth. Now, do you remember from your trig days, sine, what's the definition of sine? Remember SOHCAHTOA? Do you remember SOHCAHTOA? What's the sine? Opposite over hypotenuse. Sine is out. Now, look at this little triangle. Here's the right angle. This side here is the adjacent. This is the opposite. This is the hypotenuse. Everybody see that? What does adjacent mean? It means next to you. Your neighbor lives adjacent to you. That means next to you. So this is angle theta, then this side is next to it, whereas this side over here is opposite. What about the hypotenuse? Isn't that, yeah, but that's the one across from the right angle, so he's the hypotenuse. Everybody see that? So sine is opposite over hypotenuse. Cosine, right here, is adjacent over hypotenuse, isn't it? So that means this is adjacent, this is hypotenuse, because that's cosine. So the adjacent is minus 24, the hypotenuse is 25. Good so far? Now, okay, great, so what? Well, now I need to find this other side here, this opposite side, call it y, because it's a height. How do I find that y? How am I going to find this side right here? Pythagorean theorem, right? A squared plus b squared is c squared. Who's the c in that? Because the a and the b are interchangeable, doesn't matter.
25.
Who's the c?
25.
It's the 25, this side, because that's the longest side, right? So that's the c, that's the 25. So the other two sides doesn't matter. Y squared plus negative 24 squared. That's y squared plus 5. Use your calculator, 576, I think.
Mm-hmm.
And 625. And then you got to solve for y there. Subtract 576. So y squared is 2449. Y is 7. Okay, why did we do all that? Now we can find all the trig functions. Let's find them. But we're good to there. Am I racing ahead of you? Is everybody good to there? You're tracking with me. So again, I took that angle, put it in the second quadrant, made a triangle to the x-axis. It's got to be to the x-axis. And then I made cosine, which from SOHCAHTOA, you remember cosine is adjacent over hypotenuse. So I made the adjacent, negative 24, the hypotenuse 25, called this y, did the Pythagorean theorem, found y is 7. Now, let's do the other trig functions. So what is the sine? Well, right here, opposite over hypotenuse. So opposite, that's the 7. So right here, that's the O, opposite, over the hypotenuse, 25, 7 25ths. Cosine, we've already got, minus 24 25ths. Tangent is, what's tangent? Right here. Opposite over adjacent. Yeah, so 7 over negative 24. Everybody see that? And the other three, flip it, flip it, flip it, right? Can I just leave those off? In the interest of time, over here. Well, maybe I'll do it once. Cosecant would be the flip it, 25 sevenths. Secant is flip it, negative 25 24. And cotan is flip it, negative 24 sevenths. That's a 7 down there. Flip it, flip it, flip it. Done. Found all 6. Now, if you notice how I made this negative 24 and this positive 7 because it's up. See how this is back, so it's negative, and up, so it's positive. Back for the adjacent, up for the opposite. And that made all my signs come out correctly. If you want to be careful, and remember, back is negative, up is positive, and just be careful with that, then you'll get all your signs automatically right. If that bugs you, I remember doing this with my daughters a year and a half ago, something like that, and they're like, oh, Dad, we don't want to worry about all those positives and negatives. We just like all students take calculus. That'll work. I said, all right, girls, that'll work. Just do it. All students take calculus. Just check them at the end. Like if you want to just ignore signs all the way throughout the problem, and just at the very end, just make them right. Just don't even worry about whether that's negative. Just make everything positive. Get all your numbers, and then at the end, just do the all students take calculus. Sine is positive, and his opposite, cosecant, is the only positive one. The other 4 are negative. Since I'm in quadrant 2, I know in the end only sine is positive, and his upside down. So sine should be positive, which he did, and his upside down, which is the other one's negative, 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 negative. Yeah, so I do have it right, don't I? So you can just fix it at the end if you want. Just ignore the signs, fix it at the end with all students take calculus. That's at least what my daughters preferred.
How do we know which quadrant does the triangle list that lines up?
They told me. Good? We gotta try one of those. Super. All right, this will be a good one. Secant is 6, tan is greater than 0. First thing you got to figure out is what quadrant. Notice how they're being more secretive about what quadrant you're in. What quadrant am I in? Do all students take calculus? Let's see. So all students take calculus. So secant is, now what secant is positive, notice. What is secant the upside down of? Cosine. They're saying cosine's positive. If cosine's positive, I'm here or there. Right? They're all positive here, cosine's positive there. I'm either first or fourth. Then they're saying tangent is positive. I can't be here because tangent would be negative. The other ones are negative in that quadrant. They're all positive in the first. I'm in the first quadrant, for sure. See how I determine that? I'm for sure in quadrant number 1. It's the only place where cosine's positive and tangent is greater than 0, which is another way of saying positive. It's the only way. All right, so now you know you're in quadrant 1. Draw that out. So quadrant number 1. So just make a triangle in quadrant number 1. And when you make your triangle, are you going to go to the x-axis or the y? Is that a trick question? That's the one I beat the drum on. X-axis. You got to go to the x. Don't go over to the y. Don't do that. No. Right? I've seen a lot of students do that over the years. Just wrecks everything. Don't go to the y. Remember, because why? Because we started with 0 degrees on the x-axis. So we have to do everything with the x. So go to the x. Put your theta right there. Again, I want to give you a heads up. If you click on the Show Me an Example button, they'll show you a method that seems easier. But the reason I'm doing this now is because we're going to have to do this in the next section. So let's just learn one size fits all. Just do this well, and we got it. It's the same thing. There's a trick. They're giving you one that you could trickily do an easier way. But you have to memorize another theorem. And I don't want to memorize another theorem. And we got to do this eventually anyway. So let's just do one size fits all. So how am I going to, I need help here. Secant is 6. I don't want to deal with secant. I don't want to deal with tangent. What do I always want to deal with? Sine and cosine. So right away, convert that in for secant. Don't give me secant. What can I convert it? Secant being 6 means what? What's the upside down of secant? Cosine is 1/6, huh? Use that. Cosine is 1/6. Use your SOHCAHTOA. SOHCAHTOA. What's cosine? Adjacent over hypotenuse. So take that little triangle, write down which side's the opposite, which side's the adjacent, which side's the hypotenuse, and then make the adjacent be 1 and the hypotenuse be 6, because that's what cosine is, adjacent over hypotenuse. Right, so the hypotenuse has got to be this side, it's always the longest side, the side not touching the right angle. See how the other two hit the right angle? With the one across from the right angle, the longest one's hypotenuse? Do that one first. And then this is the adjacent one because it's next to the theta, it's touching the theta, and this is the opposite side, right? And they're telling me cosine. Cosine is a over h. So a over h. A is 1. H is 6. Now, find this other side. Call it y, call it Joe, call it whatever you want. Find it. Using the Pythagorean Theorem. One squared plus y squared is 6 squared. Everybody seeing that? The 6 has to, the hypotenuse goes alone. That's the C. It's the longest, right? The hypotenuse is the longest. The other two have to add up to be it squared, right? Solve for that side. One plus y squared is 36. Subtract 1. So y is the root of 35, isn't it? We good there? And now we can get all 6 trig functions. because now we have all three sides of that triangle. Give you just a minute. See if you can get those. So what's the sign then? Let's just go through them. What is the sign? Right here. Opposite over hypotenuse. So opposite, root 35 over hypotenuse 6. Good. Cosine we've already got. Tangent, right here. Opposite over adjacent. That's opposite, root 35, over adjacent 1. So that's just root 35, huh? And then the other three, opposite, flip it, flip it, flip it. So I won't bother. And these are all positive, aren't they? Because we're in the first quadrant. All students take calculus, we're in the first quadrant. All 6 trig functions are positive. How are we doing? Is that good? Questions I can answer on that? See how we make those triangles? Can I move on? We good? So that was too quick. Cosecant of minus pi over 4. Cosecant of minus pi over 4. So, how are we going to do that? Yeah, they want you to use even odd properties. I don't like to memorize new things, but maybe it would be helpful for you. Basically here, I'll tell you the rule. If you want a new rule, great. If you want to ignore it and do it another way, that's fine too. Cosine and secant are even functions. Now, does anybody, I'd be impressed if you did, remember what in the world an even, I know we did it, but it's been like months. It's a good time to point out you really need to study for that final exam, because there's so much to remember, huh? What in the world's an even function? Does anybody remember that at all?
It's the symmetry over the axis, or the depends on whether it's symmetric over the origin or the x-axis or the y-axis. Patrick?
Even means a certain one of those.
Yeah.
Yeah.
Even is y-axis.
Even is good memory. How do you remember that?
I don't remember.
Yeah. How I remember is I think it all comes from like an even function like x squared. That's where they're getting the even. And the odd is like x cubed. And I think, what do I know about x squared? What does it look like? It looks like that. What kind of symmetry does that have? That has symmetry right and left, y-axis. So you're right. Anyway, but more importantly, to our purposes, it means, for an even function, if you plug like a negative angle in, you can just ignore it and just make it positive. Why? Because if you go to the right for an even function, it's the same as going to the left. Positive x and negative x, or whatever you're plugging in, is the same for an even function. So whether you caught all that or not, you can go back and look at all those, whatever. Ignore the negative is what that means for cosine and secant. But the other trig functions, the other four, sine, cosecant, tan, and cotan, they're odd functions, which I won't go through the big rigmarole. I'll just say for them, so for even you ignore the negative, right? For odd, what do you do for odd? You move, you can't ignore it, but you move the negative to the front. So in other words, if somebody gives you the tangent, or like in this case, they're giving me cosecant. Somebody gives me the cosecant of a negative angle. What I can do is grab that negative and put it to the front. Do you see that? That's what an odd function, if you remember back, does. So odd functions, you can just move negatives to the front. Even functions, you ignore the negative. See how it became positive? Am I saying that clearly? Does everybody see the difference? So you can put that in your 3x5 card. Basically, cosine and secant are even, which means negatives plugged in get ignored, make it positive. The other four trig functions are odd, which means negative plugged in come to the front. Either way, we can get rid of the negatives from the inside, either by throwing them away completely for cosine and secant, or moving them to the front for the other four trig functions. So this is basically a plan for getting rid of negatives inside of trig functions, either by throwing away or moving to the front. Does everybody see the difference? So we have cosecant, we can move it to the front. Now why do we want to do that? Because we don't want negatives in there. It's kind of a pain. We just want regular pi over 4. So now we just go, okay, it's going to be negative whatever regular cosecant of pi over 4 is. What do you do with cosecant? It's 1 over sine. Right? Cosecant is upside down of sine. So now go to the unit circle, your favorite picture, right? And find pi over 4. Here's pi over 4. Cosine sine. Sine's root 2 over 2. It's the medium. So it's negative 1 over root 2 over 2. Take it, flip it. Negative 2 over root 2. You can't leave roots on the bottom. So I'm going to bring it over here. I'm just running out of space here. Negative 2 over root 2. What do we do with that? Because we can't leave that root on the bottom. Multiply top and bottom by root 2 over 2. And we get negative 2 root 2 over plane 2, right? Root 2 is root 4, plane 2. 2's cancel. Minus root 2. After all that, seems like a lot of work. Minus root 2. Are we good? So with sine, cosecant, tangent, and cotangent, move negatives to the front. Cosine and secant, just ignore negatives. Throw them away. All right, so what do y'all think? Sine 51 times cosecant 51. Says no calculator, just somehow we're supposed to know the answer. What do you think? Do you know the answer? Yeah, why would it be 1? Yeah, remember they're upside down. So this is 1 over sine of 51. So whatever sine 51 is, it cancels out, huh? I don't even know what sine 51 is, but I don't care. It cancels out. That's 1. Good. All right. 3. All right. Any guesses? If in doubt, guess 1 or 0. Usually on these ones. Yeah, 1's a good guess. 1's the truth. Let's see why. 399. Notice that's more than 360. So what do we always do when they give us an angle more than 360? Yeah, subtract it. So that's 39, right? So it's cos 39 times secant 39. And remember, secant is upside down to cos. So sure enough, 1. Easy enough. We can play this game. All right. Let's talk about what we've learned about negatives inside of sine. Remember, we never leave negatives in any of these trig functions. We either throw it away or move it to the front, depending on what trig function it is. Which one is this? An easy way to remember, only cosine is the throwaway. It is upside down. Only cosine throws away. Everybody else moves to the front. So this is going to move to the front. So I'll move that negative sign to the front. By the way, what do you think the answer is? Remember what I said? If in doubt, what should you guess at?
0.
It's probably 0, right? Move that negative to the front. So it's negative sine 23. Okay. Now what are you going to do with 383? Subtract 360. Whenever they go over 360, so we get cosine 23 when I subtract 360 plus tangent 203. Oh, that's a little tricky. Yeah, what's up with the 203 tangent thing? It's kind of tricky. They got a little. Yeah, remember what I wrote a minute ago? I wrote the period of tangent and his upside down cotan is just pi or 180. He doesn't take a full 360 to repeat values. Tan and cotan repeat values every half a circle. 180. So I'm allowed to subtract 180, which will be 23. So this is tan of 23. And this is minus tan of 23, you see, because it's sine over cosine. So sure enough, like we guessed, it's 0.
Is that going to compute for the test?
I don't know. If in doubt. Good on that. 2 more. So cotan. See what they're doing? They added pi and they added 2 pi. What did I just say about tan and cotan about their period? They repeat every pi. So if you're somewhere and you add pi, you're going to be back where you were. So in other words, this is going to be the same value as the original. And this is the same value again because it's just adding another pi. And what is cotan? So this is 5, this is 5, this is 5. Answer's 15. Do you see that? They're all the same. Because it's just adding a pi. When you add pi to cotan or tan, you're back where you started. Cotan and tan repeat their values every pi. That's what their period means, how long until they start repeating value. So if you just take theta and you add pi, we're talking about the plug-in. They told me right here, cotangent of theta is 5. If you add pi, you're still 5, you're still 5. It's 15. Well, I hope those last four aren't too bad.